Good morning. I am Professor David J. De Los Reyes. The date for today is March 17, 2023. The time is around 1:43 a.m. It's March 17. This is Professor David J. De Los Reyes. Our topic for this morning will now be still advanced mathematics. This should be lesson number 21. Okay, I will check that. This is lesson number 21. So our topic for this morning will be, this is a continuation of my long-form video on the topic advanced mathematics, and this is now advanced math lesson number 21. And the topic for this morning will be Laplace transform, formula number 7. We are to derive formula number 7 because in the so-called circuit analysis, there is a problem that is the voltage across a capacitor is actually 1 over c, the integral of I dt, right? So if we try to solve the resulting differential equation by using Laplace transform, we must have to take the equivalent of that integral thing. And that is the main topic for tonight. That is the Laplace transform of the integral of function of t dt. This should be equal to the integral from 0 to infinity of that given integral of function of t dt, and under Laplace, for us to take the Laplace transformation, this should be multiplied by e raised to minus st times differential of time. So actually, we are to take the Laplace transform of this, and this should be the formula, and what should come out will be this one. That is 1 over s, capital letter F as a function of s, plus 1 over s, f sub 0 plus. We are to derive this one by using Laplace transform, meaning if we are to solve this one under Laplace, this should be the equivalent. We are not using the so-called classical solution. We are using Laplace transform to solve that differential equation under circuit analysis. Okay, let's proceed with the derivation. If we are to integrate the right-hand side, this integral sign, this is Laplace sign, right? This is with the limit from 0 to infinity. Use our knowledge of the so-called integration, and I think the solution should fall under the so-called the integral of u dv, and this should be equal to ub minus the integral of b du. So from the right hand side, we are to choose the value of u, and the value of u that we choose is this one. This should be u. Okay, so if this is u, what remains for the value of dv will be e raised to minus st dt. So this should be dt. So actually, this falls under the integral of u dv. It's this. Okay, let's try to bring out the value of u. So from this, an intellectual guess that the value of u will be this one, right? So if this is u, what remains for the dv will be this one here. So we let u equal to the integral of function of t dt. Okay? Let's try to compute for du. Taking the differential of both sides. What you will do on the left, do it on the right. The differential of u will be du, and the differential of the right hand side will be the differential of the integral of function of t dt. That's why I place it here. Take the differential of both sides. The differential of u will just be simply du, and the differential of the integral of function of t dt, okay, what will come out will just be simply function of t dt. If this differential sign goes near this integral sign, they will try to cancel out each other, so they will try to cancel out. So if we try to take the differential, what will come out will just be simply du equal to a function of t dt or du is this one, function of t dt. Okay? The enemy of an integral will be differential, so the differential of any integral thing, they will cancel out, so what will remain will just be simply the given function. Okay? So if u is this one, dv will be e raised to minus st dt. So I place it here, dv equal to e raised to minus st times differential time. And to compute for b, we must have to eliminate this differential here. And to eliminate the differential sign on the left hand side, we will take the integral. So take the integral of both sides. Okay? So the integral of dv should be equal to the integral of e raised to minus st times differential time. The integral of the differential, okay, what will come out will just be simply p. This integral sign goes near this differential sign, they will try to cancel out each other. Right? So the integral of dv will just be simply b, and the integral of the right hand side, it falls under the exponential function, where the value of u will be equal to minus st, meaning the exponent, and du will be equal to negative s dt. Okay? It is not exact. We missed the negative s. So to integrate this one, we will introduce negative 1 over s outside. And after the introduction, this now falls under the integral of e to du. So b now will be negative 1 over s e raised to negative st. Okay? That's the integral. It's a must that we should know in the integration. Integration and differentiation at the same time. That's why we are under advanced mathematics. The requirements for advanced mathematics is our knowledge of algebra, trigo, plus your knowledge of differential calculus and integral calculus. Okay, let's proceed with the solution. I will check my camera. Oh, it's still fine. We continue with this one. Okay? The Laplace transform of the integral of function of t dt, as I have mentioned a while ago, it should fall under the so-called integration by parts. So they should be the integral of u dv, and they should be ub minus the integral of b du. So this is now just a matter of substitution. This will be u, this part will be b, and this part will be b, and this is du. We follow this. Okay, it's a systematic solution. That's why I mark the value of u and b by a red pen, so you can see it. It's easy to visualize, and it's easy to check if we got some syntax errors. Okay, so this should be u, this is b, the product with the limit from 0 to infinity minus the integral of b du. This is b, this is du. Okay? Let's try to bring out the simplification. The simplification is a little bit awkward. That's why just consider it. This is negative 1 over s, right? So I will place it first. This is negative 1 over s. Okay? Then I will try to continue with this one. But what is the equivalent of the integral of function of t dt? It is actually the given function, right? So instead of writing this one, I will write it here, function of t times e raised to minus st with the limit from 0 to infinity plus, this is now plus, why plus? This is minus, this is minus, a minus, okay, times a minus will be plus, so this is now plus. I will bring out 1 over s, so this is 1 over s, okay? Okay? So what will remain? The integral, this is the integral, right? This is an integral sign. Okay? I bring out 1 over s. This is now plus. So this is 1 over s. So what will come out, what remains inside will be the integral from 0 to infinity. I will write this one function of t times e raised to minus ed times dt. But if you try to notice it, this portion here is actually the equivalent Laplace transform of this given integral. Capital letter F as a function of s. Do not try to integrate this one. You just designate this as capital letter F as a function of s. So what will come out now? It will be negative 1 over s as a continuation, function of t. Okay? Let's now try to apply the upper limit. When time t is equal to infinity, the upper limit will be e raised to negative infinity, and they should be 1 over infinity, e raised to infinity, and they should be 1 over e raised to infinity is a very, very big number, and 1 over a very, very big number, this is almost 0. So when we apply the time t to be equal to infinity, the upper limit will be 0. Okay? We are just, what you call this, placing the limit on this function here. Okay? Minus the lower limit. So when time t equal to 0, s times 0 will be 0. Okay? So e to the 0 will be 1. So the value of the lower limit is negative 1. It's minus. We are subtracting the value of the lower limit. So this is minus 1. Okay? This is plus 1 over s. Okay? As I have said a while ago, don't try to evaluate the integral of this. Just designate this one as F capital letter F as a function of s. So the equivalent of this will now be 1 over s. This is capital letter F as a function of s. Okay. Okay, I will try to erase this one so it looks nice. So what will come out now? Therefore, the Laplace transform of the integral of any function of t dt should be equal to, we now try to rearrange. I will write first this one. This is plus, right? So this is 1 over s, capital letter F as a function of s, plus, minus, it will also become plus, 1 over s, and this is now f sub 0 plus. And what is the value, what is the meaning of f sub 0 plus? Is the initial value of f of t at time t equal to 0. The meaning of f sub 0 plus is the initial value of that given function at time t equal to 0. So formula number 7 will be, I will read it before we go for this morning. The Laplace transform of the integral of function of t dt should be equal to 1 over s, function of s, plus 1 over s times f sub 0 plus, that is the initial value of that given function at time t equal to 0. And this is now formula number 7. Okay, that's it, guys. Okay, we have derived already formula number 7. The Laplace transform of the integral of function of t dt will be 1 over s, capital letter F as a function of s, plus 1 over s times f sub 0 plus, where f sub 0 plus is the value of the function at time t equal to 0. Okay, that's formula number 7. Okay, for those who are taking up advanced mathematics and what you call this, advanced mathematics, this is for you guys. If you would like to subscribe to my channel is at youtube.com/@prof.david.j.de. And if you want to share it, please click share. Good morning, Los Angeles, from Los Angeles.